Hello and welcome to Jupyter Academy. Today we'll be solving a standard problem with geometry and with vectors. So we have just like a standard triangle called ABC and we write it like this. And what else? We have two more points here on the triangle on the AB. It is called point C1. I'll just write it this way and I will draw it. And what we know about this point is that it splits A and B into 2 to 3. Okay, so how do we write this one? We can write it as A C1. Yep. Into C1 B equals 2 to 3, and the CB, it has like another point called A1, and this point here it splits CB into 1 to 1, so we write this one as CA1 to A1B equals 1 to 1. So this is a mediana. And what do we need? We need to find out, here we have a G point, or G, it's a point. We need to find how much is AG to A1 so this one to this one, and CG to CC1. And we are starting. So how do we start here? First we select our basis vectors. And our basis vectors in this case would be AB and AC. Yep, AB would be named A and AC we would name it B. Like this, and I'm going to write this down. So vector AB is going to be named A and vector AC is going to be named B. And this tiny arrow here is the symbol of a vector. Okay, fair enough. So what can we say further? How do we continue? Pretty much the idea is to start expressing this type of lines with the basic vectors, and at the end we should be able to write some kind of an expression that equals 0, and from there we will be solving our things. Okay, so what can we say about AA1? Well, AA1 is this one. So AA1, how can we express it with A and B? Well, from the basics of vectors, if this one here was continued, I'll just express it a bit, but it's easier to understand. It was continued up to here, yeah, and then we had like a parallel vector of AC, like this, and a parallel vector of AB, like this. We would be able to say that the whole A, let's say AZ, would be equal to AC and then AB. Yeah, but in this case we don't care about this one. We only care about the half. So the half is A1 equals half of A here plus half of B. And of course we write the tiny arrow above. Okay, fair enough. Now let's express CC1 somehow. what would CC1 be in this case? Okay, CC1 would be, okay, it's obviously that it's 2/5 of A, 2 plus 3 over 2 over 2 plus 3, which is 2/5 of A. I mean, this is obvious. And if we start as CC1, then in order to get here, this vector B should be in the other direction. So we go CC1. The directions of the vectors is really important. So instead of saying vector B, because vector B is in this direction, we should need minus B. And then going all the way to 2/5 plus, okay, I write 2 plus 3, so you understand it's this thing of the A vector. Okay, so we have expressed both AA and CC. That's great. So let's take a look now at the G. And G lies first on AA1, we can say this. So what does it mean? Pretty much writing it nicely and professionally with using mathematics language. I'll just write it here, just to put everything on A4 paper. So using mathematics language, we can say that G belongs to AA1. True. And based on this, AG is parallel to AA1, which is obvious. I mean, AG parallel to AA1. And of course, we write the vectors. And from here, we can say that we can scale AG as something multiplied by AA1. For example, if it was half, it would be half by AA1 would be AG, but we don't know. But we can use something like a lambda. So we can say here AG equals lambda AA1. Absolutely makes sense. This one can be expressed as something multiplied by this one, some scalar. And we can express this AA1 as this one. So we can continue with our analysis saying AG equals lambda of minus B plus 2 and 3 is 5, 2/5 A. Okay, so far so good. We are good. And now we can continue doing the same for CC1. So in this case, G belongs also to CC1. And from here we can say that CG is parallel to CC1. And from here it follows that CG is, this time it won't be lambda, it will be something else, it would be me of CC1. True. And let's express it, so CG equals me, and here we have CC1. CC1 is this one, and this one should have been there because it's AA1. Okay, so I'll translate it. 2/5 A like this, and here I'll just write lambda times 1/2 A vector plus 1/2 B vector. Okay, so we have AG, this one expressed, and we have CG, this one somehow expressed, which is pretty much, that's pretty much how it is. And what can we say about AG now? Let's find another way to express this one, A to G, this vector. A nice way to express it would be, this vector is like B, obviously, plus CG. That's obvious, like starting from A, we go up and then we go down, and it's exactly this vector. I mean, this is the basics of vectors. So what do we write? We write here B plus CG equals AG, and these are all vectors, hence the arrows. I have something fancy here, should have done it this way. And we remove the 5 as well, so it doesn't bother us. Okay, so we have the B, and now we would try to write everything together as B, pretty much, plus CG, which is this one here, and this is equal to AG, and AG was this one here, lambda times half A plus half B. Okay, now let's open the brackets, because this would be the easiest thing. So we write B plus, and it's not a plus, it's a minus, because of the MIB, but we have something good. So B minus MIB plus 2/5 A MI equals 1/2 A lambda plus 1/2 beta lambda, and everything like this together should be, in theory, equal to 0, like from here to here to here to here, like going all the ways, like this, this and this, it would return us on the basic vector. So how do we write this thing? That's a good one. We would move this one to the left, so it would be beta minus MIB plus 2/5 A MI minus 1/2 A lambda plus, and it will be minus because it goes to the left, 1/2 beta lambda, and all this should be equal to the 0th vector, like this. So what can we do? We can try to take a look and say, okay, all these 5 beauties, they have either B, our basis vector, or A, our other basis vector. So we're gonna put B and A outside of the parentheses, just so we would try to understand. Now it will be challenging how to build it, but let's see. somewhere here. So this is 1, this is 2, this is 3, and we continue with the challenge. And the challenge continues with us. So a outside of parentheses, and in the parentheses we should be having minus. Okay, we'll be having 2/5 me. Makes sense? Yep. 2/5 me or mu, depends where you learned it, minus 1/2 lambda, and then the next one would be plus b, and here we should have, for this one, it should be 1 minus mu, this is 1, minus mu, minus 1/2 lambda, and all this should be equal to the 0th vector. Yeah, makes sense, at least the way we see it. And now, there is a rule that if we have the basis vectors, like this, if we want to make sure that they are equal to the 0th vector, then this thing here and this thing here should become zeros, because to have the basis vectors turning up to a 0 and returning 0 vector, then the rule is that in our case it should be a times 0 plus b times 0 should return the 0th vector. Okay, so the question is, how do these things here turn out to be 0? And the answer is, let's build a system. So 2/5 me minus 1/2 lambda equals 0. I'll not write here the 0 vector as a vector, it should be understanding. And then 1 minus me minus 1/2 lambda also should be equal to the 0 vector. And now let's solve the system. How do we solve the system? We'll try with expressing me here. Okay, so let's see, me from here is equal to, this one goes to the right, so it is 1/2 lambda, and then we should divide it by 2/5, which is actually equal to 1/2 lambda multiplied by 5/2. Yeah, so me should be equal to 5/4 of a lambda. Well, that's fair enough, I would say, like this. This is important. And now let's replace in the second one. So we have 1 minus 5/4 lambda minus 1/2 lambda equals 0. So we simply increase here with 2. Fair enough, I would say. So we have 1 minus 5/4 lambda minus 2/4 lambda equals 0. I'll leave this one. So minus 5/4 minus 2/4 should be 5 and 2, 7, 4. So we have 1 minus 7/4 lambda equals 0, and from here lambda should be 4/7. Lambda equals 4/7, and with lambda equaling 4/7, me here would be 5 over 4 lambda. So me equals 5 over 4 times 4 over 7. And this is 5/7. Okay, fair enough. So what does it mean? 4 over 7, 5 over 7. Let's take a look and see what exactly is lambda and what exactly is me. Okay, so here AG equals lambda times AA1. AG equals something times AA1, some kind of a scalar. So in order to make this one equal to AA1, no, in order to make AA1, yes, the big one, equal the tiny, we multiply it by 4 over 7. So this one is pretty much 4. And this one should be 7 minus 4, so it should be 3. And it should be exactly like this for the next one. 5 here. And 7 minus 5, so 2 here. So AG to AA1 is pretty much 4 over 7. And CG over CC1 is 5 over 7. Yeah. And so far so good. Let's take a look and solve this one now with Python and see how much are we going to get there. So, and now here we are with Python trying to solve the same. And let's take a look. First we declare lambda and me. They are named lambda1 and me1 because if you just write lambda like this in Python, this is one of the 30 words that cannot be used for naming a variable. So lambda1 is perfect. And this is how it looks. If you look for lambda1, it's fancy. Same for me. For me, you can use mi, but just to make it standard, it's okay. So we define, and here I'm explaining pretty much what I did on paper, with the intersection, the coefficient comparison for A and B, and we're using this fancy EQ thing, with the lambda, the 2/5, the halves that we're having. See, solving the system just takes one line, and what actually it does under the hood, it's its thing. Then we calculate the lambda value, where lambda represents AG over AA1, of course. We run it, and we get 0.57 and 0.71. Let's take a look at our paper. So 0.57 should be equal to 4 over 7, fair enough. So 4 over 7 is 0.57, and the next thing that we had to do was 5 over 7, and 5 over 7 should be, yeah, 71 something, exactly. So now let's draw the triangle with Python. So let's solve further with Python and plot our beautiful triangle. First we define the points A, B, and C. It's obvious that it's easier to write the basis vector as orthogonal triangle. Why is it obvious? It is obvious because it is easier, so we go for the easier. We calculate the ratios, and we can take a look. If we run this one here, for example, if we have A1, it would say 0.505, so pretty much A1 is split exactly, and C1 for X and Y would be 0.4. So on the X it would be 0.4, on the Y it would be 0.0, and 0.4 is actually 2 to 3, from 0, 4 to 1, so to say, which actually means if we divide 4 by 10, it would be 0, 4. It would be easier once you take a look and understand the whole thing later, once we plot it. And now for the plot, that's the figure, that's the size, that's the medians and the Cevians or the Cevians, depends how you read the names of the famous Italian mathematician. It's Cevian or Cevian or Giovanni Ceva, yeah, with his theorem, which we are actually working on right now a bit. Highlighting points, annotating points, and running everything, and this is how it looks. Okay, so this is what I meant with 0, 4. And you see the G point. Yes, yeah, actually a nice place. The median is this one, so it is exactly 0, 5, as you see here in 0, 5. This is what I meant when I showed this one. See, 0, 5, 0, 5. So far so good. I hope you enjoy these new types of videos, and let me know whether you find them interesting. That's so far everything from me. Enjoy the rest of your day. Goodbye, take care.